Everyone, this is Matt with Learn Everything About Design, and in today's video we are going to cover all the constraints in Fusion. We're going to talk about what they do and some of the basic use cases for them. Now, this is a question that came up in one of our absolute beginner series on learneverythingaboutdesign.com, and essentially in that series we look at the basics of CAD, in this case of part and sketch modeling, and we go into assemblies and forms and surfaces and all that kind of stuff. But in there, we cover the basics, the sort of ground level core functionality that you need. But the question came up if we could cover all the constraints, if we could dive a bit deeper. And so in this video, what we're going to do is we're going to cover all of that as kind of an extra bonus so that people can understand what the constraints do. In most cases, there are a handful of constraints that we use over and over again. But in this video, we'll talk about all of them, so hopefully you have a good idea as to what each constraint does. And if you want to follow along, you can go to the description and download the data set. It's basically a bunch of different sketches, so when you go to that link, it may say that it's an empty file because there's no solid geometry in it. I'm going to go ahead and toss a solid block in there just so it doesn't throw up an error. The block is really for nothing. It's just, you really just want all of the sketches. So the first sketch that we're going to take a look at is Coincident. So we're going to start by editing the sketch, and we want to take a look at the coincident constraint. Now, the coincident constraint can be used for a bunch of different things. Coincident generally means that two endpoints are touching, but there's actually another way that we can use this. So first way that we're going to use this is by taking the endpoint of this line and selecting the origin. So again, common use case, you would have the endpoint of the line attached to the origin or some other point. You can also select the endpoint of a line or other geometry and snap it to things like arcs and circles. So we can do that with this line as well. We'll take this endpoint, snap to the smaller diameter circle, and this one, and snap to the outer diameter circle. Now, the other way that we can use this is to actually select the line itself and, in this case, the center point of the circle. Now, what this actually does is it allows the line to always go through the center of that circle. And so this can be helpful in a couple different ways. I'm going to hit Control Z to undo, and I'm going to move these endpoints around to show you the other way that this can work. And so if we select the line, Control select the origin, and use Coincident, now the endpoints of the line are still attached to that circle, and we can drag this around so that it's always pointing at the origin. So if you're trying to make segments inside of a circular region, this can be helpful to make sure that it's always pointing directly at the origin. The other way that we typically do this is with a construction line that's parallel or collinear, and we always have that construction line in there. But this can get pretty messy when the sketches become more complex, so using the coincident option can be a great way to do this. Of course, then you can use things like dimension tools, and you can always keep them at a specific angle, and that just, again, gives you a fully defined sketch. So let's go ahead and finish that sketch. We'll hide it, and now we'll modify the second sketch, which is horizontal vertical. So this is one that automatically gets applied quite a bit when you're sketching a line. If you're close to vertical or close to horizontal, it'll snap to those positions unless you hold down the Control or Command key, which temporarily overrides those persistent constraints. There are settings that deal with this, but for the most part, I leave it on and just hold down Control whenever I get close to those areas, so that way it doesn't snap. But in most cases, we're applying this after the fact. So for example, if we have this line here, it's close to vertical. If we click on horizontal vertical, it'll go to that orientation. Another thing I do want to point out in this instance is that our right-click menu is going to be somewhat contextual. Everything you see here at the bottom, those are things that are on my S key menu. But if we select a line and right-click, it's going to present us with the various sketch constraints that we can use. So in this case, fix, unfix, horizontal vertical, and delete coincident. So this option right here can actually be pretty helpful because in many cases, it can be hard to find the constraint that you want to delete. Notice that it's not really showing the coincident until we hover over or select the end. If I right-click on this line, notice that I can delete the coincident, again, because it's hidden. So what we want to do now is we're going to select the line, right-click, and make it horizontal vertical. Again, because it's close, then it automatically will go to the closest one, either horizontal or vertical. There are other ways that we can do this. For example, a sketch point on a circle, we can make it horizontal or vertical to the origin point. We can also make these points horizontal or vertical from other geometry. The same is true for things like sketch points. We can do it between sketch points or between the origin, and we can have those sketch points, lines, curves, all these different sorts of entities snap to a horizontal or vertical position. There are many sketch entities where this automatically will happen. Again, lines are one of them. Rectangles are often one of them as well. Depending on the type of rectangle you create, you may find that you get different constraints. So for example, a center rectangle has one horizontal, a perpendicular, and then a bunch of parallel constraints. The 2-point rectangle has all vertical, horizontal. And again, these are just differences in how those two different tools are applied. But again, a lot of these are persistent. You can go through and you can delete them if you want. You can change or undo them. But a lot of times they do get created automatically. All right, the next sketch constraint is tangent. So let's edit the tangent constraint. And this one is essentially going to be a coincident constraint, and a tangent constraint are going to be sort of the next level. Coincident means that 2 points are connected. Tangent means that the direction of curvature is the same. They're not mutually exclusive, meaning that we can have a line that's tangent but not actually connected. So for example, select tangent. We'll select this horizontal line that already has a horizontal constraint, and we'll select the circle. And notice that it's keeping it tangent, but they're not connected. If we were to use the coincident constraint between that endpoint and the circle, it'll extend it out, and now it is intersecting with that. If we do the same thing, again, tangent between this arc and this line, it'll make them tangent, but they're not necessarily connected. Meaning if I hit escape and I start to extend this line out, notice that they are tangent. Basically, the curvature is the same at that intersection point, but they're not intersecting because this curve can get bigger or smaller. And so in order to fix these, what we would do is use coincident between the endpoints, and then we would get that nice smooth transition. Now this works with more than just arcs and lines. We can also do this between circles. So for example, we can have these two be tangent. We can do it between splines. We can have splines be tangent. The one requirement here is that the splines actually do need to intersect. So you will need to do coincident first between the endpoints, and then we can use tangent between the curves and make sure that the direction of the handles are in the same orientation. So essentially they're parallel or collinear. So tangent can be used in all sorts of cases. Most of the time you end up doing tangency between lines and arcs in most basic sketches. As you start to make more complex sketches, you'll use it between splines and other geometry. So let's finish the sketch and let's go to the next constraint, which is equal. Now, equal is fairly straightforward. It just makes two selections the same. This can be used on things like lines or arcs or circles. And so in the case of equals, we're going to select the two inside diameters and then the two outside diameters, and that makes them the same. So if I hit escape and I start to change the size of one, the other one is going to change. It's not based on position, so that doesn't matter. But if I apply a dimension, let's say 15 millimeters, that means that the inside diameter of both circles is always going to stay the same. Doesn't matter where they are in the sketch. Equals can also be used on things like lines. Most of the time you'll see it used when you're creating a perfect square out of a rectangle. And again, it's just a constraint that says the two things that we have selected are the same. We can do this in other ways. So for example, if I select and delete that constraint for equals, and I apply a diameter here of 40 millimeters, I can apply a diameter to this circle, click on the first one, and then relate those with essentially a relationship on the parameter level, saying that the diameters are the same. One thing that I would say is that the equal constraint can oftentimes be more helpful because it keeps the sketch cleaner. We don't need to have a bunch of extra dimensions on the screen if the intent is always to keep them the same. The only reason that I would generally link these together is if I potentially want to create some sort of variation of this, let's say plus an extra 5 millimeters to make it always 5 millimeters larger than this one. So we set this at 45, it makes that one 50. So the dimension functionality can be the same as an equal constraint, but it can also have extra options such as creating some mathematical operator to set the size of that feature. The next one we want to take a look at is parallel. Now, parallel, again, is going to be essentially used on lines, but there are cases where you may decide that parallel is the right choice. Sometimes it's horizontal vertical, sometimes it's perpendicular. And so an example of this is if we want to make these two lines parallel with each other, knowing the bottom line is horizontal, if we make the upper line parallel, then we're creating this sort of parallelogram. If instead we wanted to ensure that there was a 90 degree between these two, we would instead go to something like perpendicular. And it always comes back to the design intent. We need to decide what we want the shape to be, how we want it to change when we manipulate dimensions. So in this case, we can change the angle, we can change the sizes, and we can always maintain that perpendicular relationship between these two edges and parallel between these two. Now, in many cases, there will be other options that we can use to achieve the exact same result. And this is one of those cases. If I delete the parallel constraint and instead use perpendicular between those two, this automatically forces those two edges to be parallel, simply by the fact that this is at 90 degrees and this is at 90 degrees as well. So again, you have to look at the design intent to decide which constraint is going to be the best option. In many cases, parallel is automatically applied, just like things like perpendicular. You'll notice that oftentimes you'll snap to a certain orientation. If not, then you'll get to a position where you have a parallel constraint that's happening between other geometry or a perpendicular constraint. Again, it depends on the sketch entity that you're drawing. All right, so that's parallel. Let's hop into one that's just perpendicular. Again, very similar. Parallel and perpendicular in a lot of use cases can be used interchangeably. It simply depends on the design intent. But perpendicular is made to keep two sketch entities, in this case lines, at 90 degrees to each other. More commonly, it's used on those center point rectangles, and also it is automatically applied when you're sketching. So that's something that you can do here. You can automatically apply that perpendicular constraint. This is something that you can do on sketch lines. Most of the time, you will be driving a perpendicular constraint instead of parallel on things like rectangles, and parallel will oftentimes be used on irregular shapes, not traditional rectangles or squares. Next, we're going to go to fix, unfix. Now, fix, unfix is essentially what it sounds like. It's locking geometry. So you would use fix, unfix to lock the position of some sketch entity if it's hard to define. I would generally use fix, unfix as a temporary solution, or if I have an extremely complex sketch, something like this spline, there may be cases where I decide to fix or unfix certain control points just to keep references in the right location. So for example, if I want to fix and unfix those three locations, I'll hit escape. Now, as I move the rest of the spline around, I know that I've got geometry around where that circle is, and I can manipulate these, but the center point is locked and these points are locked as well. Once again, this is probably one that's used very few times in practice. It's more of a temporary solution while you're building out a complex sketch. Something that I don't personally use is auto constrain, but in cases like these complex splines, you can use the auto constrain option. It'll go through and it'll try to apply dimensions and constraints. Something like this you can see looks quite crazy. So using fix unfix for a shape like this might be a better solution. So it really depends on what you're doing. Next, let's take a look at midpoint. So the midpoint constraint, and also a new addition we have is a midpoint line, but a midpoint constraint will essentially set the selected endpoint to the middle position of the second selection, in this case a line. This doesn't add a perpendicular or parallel constraint automatically. It just simply says this point that we selected is going to go to the middle of this line. Where this gets a little bit tricky is when we have two lines and we don't have the ability to select the midpoint easily. There are supposed to be ways in which we can select the midpoint in the lines, but generally what I do is I take sketch points, I drag them and snap them to the line and find where that midpoint is. So for example, we'll come here And then I can either use coincident between these two midpoints, or if I've got an individual line, I can select the line and the point and use a midpoint constraint there as well. And so again, it depends on the use case. You will oftentimes use midpoint to get the center of two lines together. In some cases, you might find that you're just using the endpoint of a line to the midpoint of another. Most cases that I use this will generally be with construction geometry, and I will oftentimes use that construction geometry for various purposes, but most of the time when I use a midpoint constraint, it's going to be with construction geometry. Let's go ahead and finish that, and we'll look at concentric. So concentric is something that you use on circles or arcs. Generally, what it does is it puts the center point of those at the same location. So this is another one where we could have multiple constraints that get you to the same point. So what I'm going to do is just copy and paste this so we can show that as an example. If I use coincident between the center points of those two circles, or I use the concentric between these two, it's going to give me the same result. Now, when we have arcs, again, we can see the center point of the smaller arc, the center point of the larger arc there. When we select them, it's going to put their center points at the same location. And so that way we can play around, we can make one bigger or smaller, but it's going to keep the center points at the same location. So once again, coincident on the center points or concentric on the arc selections, both of those are generally going to give you the same result. All right, let's go ahead and finish that, and we'll take a look at Colinear. Now, Colinear is something that can be pretty helpful, and essentially what this means is two lines are going to be along the same vector infinitely. And so when we use this, for example, these two lines are parallel, which means that they are going to be going the same direction, but it doesn't necessarily mean that they intersect. If we want them to intersect, we can use something like coincident to put them together. But if we don't want them to intersect, we can use a tool like Colinear. This means that they're always going to be going the same direction, but they don't necessarily have to be coincident or touch each other. An area where I use this is generally with laying out references for moving parts like two parts of a shock, for example. And in this case, what I'll do is I'll create a midpoint to midpoint line on each of these rectangles. I'm going to convert it to construction. I use X on the keyboard, but you can use up here. And then I'll take their center lines and I'll make them colinear. And so what this means is these will move in and out of each other. And this gives me a good reference for something like a shock. I can put the end point of this line at the origin, which means that they're going to rotate about a pivot point and move in and out. This helps me lay out complex mechanisms in 2D. Fusion doesn't have something like sketch blocks that you see in SolidWorks or in Inventor or other CAD programs. So this is a way that we can do this. And generally when we drag this around, we want to temporarily disable the persistent constraint. So you hold down Control, and that way you can create a mechanism to replicate that motion before you build out your parts in 3D. We've talked about this kind of thing before when we did our suspension geometry layout video, probably 3 or 4 years ago at this point. But this is a nice tool that we can use, and Colinear, that's probably the main case where I use it. All right, next up is symmetry. Symmetry is what gets applied when we use the mirror tool. And so, for example, what I'm going to do is convert this to a center line, and I'm going to just draw something. Let's just draw something over here, some shape, and hit Escape. I'm going to double click that and use mirror. It's going to create a mirrored version on the other side, and you'll notice the constraint that gets applied is this symmetry constraint. And essentially what it's doing is it's looking at each endpoint and it's making those endpoints the same distance from that reference line. This can be done by selecting the first object, the second object, and then the mirror line, and then manually applying symmetry in that way. Notice that the lines are different in this case. I'm going to hit Escape. So notice that as I move these around, it's not keeping the line length the same. It's only keeping the orientation the same. And so what you need to do is select the endpoints and the midline and set them at symmetry. Do the same thing here. And so for me, this has a limited use case over using something like mirror. It works when you've got standard shapes like a rectangle or a circle. And so we'll select that. Well, I had something else selected. Let's go ahead and grab this. Let's try this. That, and that. Yeah, I think there's something else selected here. Had this selected for some reason. But it works for, you can see it applied it. It works for regular shapes like circles and rectangles. It does not work for irregular shapes. This shape, if I had manually drawn it and tried to use symmetry, it would not work. So in those cases, what you have to do is select the mirror tool, which will automatically apply symmetry. And you notice it does symmetry for each point along the part. And that's the way that it makes it work. So this is a constraint that I almost never use, simply because if I want that geometry, I typically use mirror. It handles it for me. And there are a few cases where it can work. Next up is curvature. So this is an extension of tangency. When we looked at tangency before and we looked at it with splines, we saw that the spline handles were going the same direction. When we use the smooth or curvature constraint, this is G2 continuity, which means the direction of tangency, but also the radius of curvature is going to be the same. And just like before with tangent, what we need to do is first connect these endpoints together. So we're going to go ahead and bring these together, and then we can use the smooth constraint. And so once again, what this does is it controls the direction of curvature, but also the radius of curvature, which means that you get a smoother connection between the two. So if we have something like a line, let's go ahead and just create a spline here. When we have something like a line by definition has no curvature. It's completely straight. There's no radius. An arc or a circle has a consistent radius, while splines have a variable radius. They're constantly changing. And so when we go to apply something like a tangency constraint between these two, what it's doing is it's driving the direction of that handle. So you can see it kept the handle the same length. It just rotated it so that it was essentially collinear. If I undo that and I select these two and I use the curvature, what this does is it drives the direction, but also the length or the weight of that handle. Now, this is one of those odd use cases where it produces a slightly different result, but mathematically it probably shouldn't, because there is no curvature to drive the distance of that handle. But again, you just need to play around with these and figure out what works for you. In most cases, I will default to using tangent if I'm dealing with a line or a consistent radius like an arc. And if I'm dealing with two splines going together like these two, typically I'll go to the smooth constraint. And next up, we want to talk about Polygon. Now, Polygon is a weird one. This one got added in one of the last few releases. I don't remember which one. But essentially, you already have to have a perfect polygon for this to work. And so if we double click this, go to constraints and say polygon, it adds a polygon constraint, which essentially means that it's keeping all the sides the same length. If I snap it down here, I can go ahead and rotate it around and change its size and so on. But once again, this really only works if you have got a true polygon already. If you try to draw one, let's say I just create one that's relatively close to a normal polygon and double click on this and try to apply it, it doesn't work. And so I have found sort of limited use cases for this. Typically, if you've got a polygon like this and you offset it, let's go ahead and offset it inward. This does not have the same constraint. Let's go ahead and kind of rotate this around. You'll notice that it doesn't really have the same constraint system. So generally, if you copy or offset, sometimes you'll have to go back and use the polygon constraint and add it back. And that's really the only time I found it useful. In most cases, it doesn't work if you're just trying to draw a polygon and apply it. But that is going to be every constraint that we have in Fusion. There are other applications, there are use cases where you'll come up with some odd scenarios where there work. But again, these are probably some of the more common ones. Coincident, horizontal, vertical, tangent, and maybe equal are probably the four that I use the most. And then when I get into complex splines, a lot of times I'll get into tangency or curvature. Most of the other ones are either automatically applied or used randomly for various things like the midpoint constraint or collinear. But in most cases, if you have a solid understanding of how basic constraints work, you'll be able to apply any of these. And just keep in mind that when they are applied, if you ever want to change it, you can always select them and delete them and decide that you want to change them or make adjustments at any point in time. If you have any questions on this, please let me know. If you want to see more examples of constraints, I can probably come up with a few, but in the most cases, this is going to cover 99.9% of your use cases. But again, any questions or comments, leave them below. If you want to check out the courses that we have for absolute beginners, if you're just getting started and you're trying to learn how to model, I'll leave a link to our learneverythingaboutdesign.com website, where we have both beginner all the way up to advanced courses on design, and we're always trying to add more to that website. So be sure to check that out if you're looking for some more content. And as always, thanks for watching, and we'll see you in the next one.